All right, so for solving this problem, or in this case actually simplifying it, we're looking at a big ugly fraction, and in order to simplify it, we're going to use the same kind of rules as what we normally use. We are going to go through and we're going to cancel out anything that I can divide out of both the top and the bottom. Now as you take a look there, there's actually stuff we can divide out. So for instance here, the x plus 8 and the x plus 8. Notice that I have an x plus 8 that's multiplied into the entire top, and an x plus 8 that's multiplied into the entire bottom. Because it's all being multiplied there, I can go ahead and cancel. Now, yes, life would be much different if, for instance, I had a plus 1 or something like that hanging out here that wasn't multiplied by everything else. That would screw everything up. But because we don't have that, yeah, we can go ahead and just start canceling. And so that's why this one ends up being actually a fairly easy problem. Because I just look and see, okay, do I have an x minus 1 in the bottom to cancel with the one on the top? Yes, I do. Okay, I can cancel that then. Is there an x minus 2 in the bottom that I can match up with the x minus 2 on the top? No, there isn't. So that one stays. The x plus 5, is there one of those in the bottom that I can match up?
Yes.
Yes. And so I'm just going through and canceling those. Now, having done that, I still have this out front. I didn't deal with that at the start. We need to come back and we need to deal with it there. So I'm now reducing that part of it, which requires a couple different little pieces there. First of all, the 15 and the 25. What can I divide both the 15 and the 25 by? 5. Okay, so then we're going to be able to do that. We can go ahead and divide top and bottom by 5. If we do that, then that's going to become a 3 and a 5. Okay, and what about the x to the 5th and the x cubed? How many x's, just plain old x's, not x plus or minus anything, but just plain old x's, how many x's can I cancel out of both top and bottom? It'd be the x cubed that gets canceled there. So yes, 3 of them cancel out, which means that I'm left with 2 x's multiplied in the top and none in the bottom, because I'm canceling out all 3 of those, and I'm canceling out 3 of those to leave us with 2. If I do all of that then, this is what I'm left with. I was left with the 3x squared and the 5, and then the only parentheses that were left for us to deal with were the x minus 2 and the x plus 2. And really, I'm okay leaving my answer this way. Yes, you could expand it out, but expanding it out isn't going to let us do anything more than what we can do already. In fact, what you're going to see today is that these problems are actually much easier when they're factored. And so, with that idea in mind, let's see how we would simplify this fraction. So right now, as we take a look at it, if I were just looking with the basic rules of how we reduce a fraction, I couldn't do anything here. Because remember, I'd have to divide the same thing out of every single term. Well, there's nothing that divides out of all 6 of those. However, if we instead see that this is factorable, we might see there actually is something we can divide out by factoring. And so let's go ahead and factor the top of this. And so x squared plus 5x plus 6. What are the 2 numbers that would add to 5 multiply to 6? Multiplying to 6, that would have to be 2 and 3. Bringing us back to our quadratic factoring, right? And then on the bottom, the 2 numbers that add to 7 and multiply to 10. Remember, you start by thinking about multiplying to 10. That'd be 5 and 2. Once I've factored it, now I can go ahead and worry about reducing it. Now can I see anything multiplied into both the top and the bottom? Yes. You'll notice that the x plus 2's appear on both the top and the bottom. So I can go ahead and cancel those out. And doing so leaves us with just x plus 3 on the top and x plus 5 on the bottom. And then that one's done. That's as good as we can make that one. There's nothing else I can do to those 2. So now here's another simplifying problem. Again, same basic idea. When I first look at it, there's nothing I can divide out of all 6 terms. That is the 3 on the top and the 3 on the bottom. But I do have a couple quadratics, and I hopefully can factor them. So go ahead and do that. Factor both the top and the bottom. So when looking to factor these, the first thing I'm doing is really, I'm just factoring the top and then I'm factoring the bottom. So I'm treating it basically as two separate quadratics at the moment. They don't need to relate to each other. So just looking at the top, the first thing I want to do when factoring a quadratic is see, is there anything I can factor out of every single term, just of those three? Notice there is. What can I divide all three of those on the top by? 2. And so we're going to do that first. And on the bottom, what can I divide everything by? Doing that makes our lives a whole lot easier. Yes, we have dealt with quadratics where you can't just factor that number out. And there, yeah, we'd have to use a guess and check or a box method to factor it. But here we don't have to, thankfully. Makes our lives easier. So, now that we've factored out the 2 and the 5, factor the remaining quadratics. Yes, each of those is factorable. All right, and then we go and we factor each of the remaining quadratics. So the one on the top, the x squared plus 5x minus 24, I'm looking to see what can I find, what two numbers add to 5 and multiply to negative 24. Same kind of thing on the bottom. And you should get these as your factored forms. Now that I have completely factored the top and the bottom, I now can go ahead and reduce. So what's in both the top and the bottom that I can cancel out? The x plus 8. Okay, so I can cancel out the x plus 8s. What about the 3's? Can I cancel the 3's? No, I can't. Because it's not just a 3. It's x minus 3 and x plus 3. They are not the same. I can't make them the same. And so no, those are going to stay separate. And so then this is our final answer. And yes, you could also give it as 2x minus 6 over 5x plus 15. You could distribute in if you want to, but you don't need to. And since you don't need to, just go ahead and leave it like this. Leave it in the nice, pretty factored form. It's more useful anyway. All right, so taking a look at this problem now. Again, we're going to look to see, well, first of all, can I just simplify it as it is? Is there anything that I can divide out of every single term on the top and the bottom? No. Unfortunately, no. We're close to being able to pull x's out of every term, but that 36 gets in the way of that. But yeah, there's nothing I can divide out of all of them. So then we go to factoring. And the first layer of factoring that's good to start with is just look to see, can I divide the same thing out of every term on the top or out of every term on the bottom? So looking at the top, is there anything I can divide out of all three of those terms? Factor out of all three of those terms? No, not in that case. Not on the top, at least. Because like the x to the 4th, the 36, there's nothing that comes out of those. We will be able to factor it, though. But we're going to get to that in a minute. On the bottom, is there anything I can divide out of all three terms? Well, I do see something popping up in all three of them. Notice all three of them include x's. And because of that, I can go ahead and factor out some x's. How many x's can I pull out of every single term? 2. So that means I can pull out that x squared. And so just doing that much gets us to this, which at least seems like progress, because this now seems like a much simpler quadratic to deal with on the bottom. On the top, though, I said that is factorable, and it is, because that requires going back and remembering that we can factor something that's not a quadratic, like in this case our quartic, if this exponent is twice this exponent, because it behaves like a quadratic. So I can still say what two numbers add to negative 13 and multiply to 36. And so we go through, oh yes, we can remember it is negative 9 and negative 4, very good. And so we can write our factored form. And notice in our factored form here, though, going back, remembering how we deal with these quartics, you notice each parenthesis doesn't start with x, it now starts with x squared. It starts with the same thing that was in the middle back here. And so I just use that for doing the factorization at that point. Well, having done that though, notice now the x squared minus 9 that gave us, that's still a quadratic. Can I factor x squared minus 9? Yes, we can. That's the one that becomes x plus 3x minus 3. What about the x squared minus 4? Can we factor that one? Yes, because remember, if it's x squared minus a perfect square, then we can do it. And so both of those factor even further. So this is really what we're dealing with here. This is as factored down as it will go. Notice I didn't worry about doing any reducing after I checked to see if there was simple stuff at the start. I haven't done any reducing along the way or anything. I was just trying to get the top and the bottom as factored as I could. Once we have the top and bottom as factored as we can, then we can look to see what can I cancel out. What appears in both the top and the bottom that I can actually remove? Well, start looking for pairs. The x minus 3 here, does it have a partner in the bottom? Yes, it does, so those will cancel. Because it's all just multiplied together on the top and all just multiplied on the bottom. What about the x plus 3? Does it have a partner on the bottom? No. Okay, the x minus 2. Does it have a partner on the bottom? Nope, so it stays put. And the x plus 2, does it have a partner on the bottom? Yes, it does. And so I can go ahead and cancel those out. By doing that, we end up with our most simplified answer here, which is x plus 3 times x minus 2 all over x squared. And having seen that, a little side question here. If I multiplied out the top here, I'd have x squared plus x minus 6 all over x squared. Can I cancel out the x squareds?
Yes.
Question. And this is the question you have to ask yourself in order to know that answer. Can I take the x squared out of every term in the top and the bottom? I can't. No, I could take it out of those two, but I can't take it out of these two. If I can't take it out of every one of them, I can't take it out of any of them. And so then that's why this actually is our simplest form and why we wouldn't bother multiplying it out to try to simplify it further, because it's going to give us stuff that won't cancel out with that x squared. All right, and here's our next problem that we're going to be doing, because of course we've not just been simplifying these rational expressions, these fancy fractions, these complicated fractions that we call rational expressions. We've also been adding, subtracting, multiplying, and dividing them. And so we will continue to do so. Now this is a multiplication problem. And so we follow the same multiplication rules that we always follow when multiplying fractions. And that is multiply straight across the top and straight across the bottom. In this case though, it might be tempting to go ahead and start by turning it into x squared plus 4x minus 21 on the top. But I actually don't want to do that, because doing so is going to give me a quadratic over a quadratic. And how did we reduce those types of fractions just a minute ago? We had to factor them. Well, if we leave it in terms of the parentheses here, it's already factored. Notice that if I write it just as x plus 7 times x minus 3 on the top, and x minus 4 times x plus 7 on the bottom, it's already in factored form. It's now in the easy form in order to be able to reduce it. So you don't need to expand them. Not unless you got to combine some terms or something like that. All right, so seeing this, will it reduce? Yes. We got a pair of x plus 7s there that are going to go away. And so this actually reduces down to be just x minus 3 over x minus 4. Now, having done all those other problems, I think you can do this one. Because I have division of fractions. We recently were talking about division of fractions in previous lessons. And in this lesson, we also saw that whenever we got these quadratics in there, what am I always doing with my quadratics? Yes, we factor them. And so in order to attack this problem, the first thing that I would do is factor every single one of those quadratics. And yes, there's 4 of them. But I tried to make the numbers easy so they go fast. All right, and then once we've factored each of those quadratics, now deal with the division. And so to do the division, we multiply the first fraction by the reciprocal. And now that I'm multiplying fractions, I just multiply straight across the top, straight across the bottom. And now, hopefully it's easy at this point. When you first saw this today, it looked complicated, it looked scary, but now hopefully you see, oh yes, this is easy, because all I got to do is look for pairs of parentheses that match up. And so look for anything that appears in both the top and the bottom, cancel those, and in this case we're left with just x minus 8 over x minus 7. That's it. Much simpler than what we started with, that's for sure.